In this video, we shall be discussing about prototypes. In the previous video, we have seen what do we mean by usability testing, what is the purpose of using usability testing, and 4 different types of evaluation methods. So now we shall look into what are the various different types of prototypes. A prototype is a simple incomplete model or a mock-up of a design and is primarily a vehicle for exploration, communication and evaluation. Its purpose is to obtain user input in design and to provide feedback to the designers. Its major function is the communicative role it plays, not accuracy or thoroughness. A prototype enables a design to be better visualized and provides insights into how the software will look and work. As you know, it also aids in defining tasks, their flow, the interface itself, and its screens. Thus, a prototype is a simulation of an actual system that can be quickly created. A prototype may be a rough approximation, such as a simple hand-drawn sketch, or it may be an interactive prototype allowing the user to key or select the data using controls, or it may also permit us to navigate through menus, retrieve displays of data, and perform some basic system functions. A prototype need not be perfectly realistic, but it must be reasonably accurate and legible. A prototype also need not be functionally complete and processing the actual files or processing the actual data. Today, many software systems support tools for prototyping are available that permit the prototype to be integrated directly into the application code. Thus, a prototype may have a great breadth, including as many features as possible to present the concepts and overall organization. Or it might have more depth, including a more detailed on a given feature or task to focus on individual design aspect. Thus, by nature, a prototype cannot be used to exercise all of a system's function, just those that are notable in one manner or another. Prototypes are useful early in the design phase and should be capable of being rapidly changed as testing goes on or is performed. A prototype is characterized by its fidelity, the exactness and thoroughness of its replication of systems, screens, and user interaction. Prototypes may range in fidelity from low to high, from rough hand-drawn sketches to some fully functional software. Low fidelity prototypes are usually paper-based and include sketches and scenarios, and interactive prototypes. They can be prepared by hand or by using a drawing package like Microsoft Paint or PowerPoint. High fidelity prototypes are softwares based on yielding a functional version of the system that can be interacted with. Therefore, we have various kinds of prototypes. Now, let us discuss these prototypes in the order of increased fidelity. So, to begin with, we shall begin with hand sketches and scenarios. Hand sketches and scenarios is the very first and the simplest prototype and is of low fidelity. Here we make use of rough hand-drawn sketch or a mock-up of the screens. These can start early in the design process and before any attempt is made to create a prototype using an available toolkit or an interface builder. With sketches, the focus is on design of individual screens. But whereas we are not trying to concentrate on the interface mechanics. The hand sketch should be an entity that has enough of general look to suggest the functionality, interaction and the layout of screens. The goal of this rough version is just an example of a polished an example of not a polished work of art. This sketch will be useful in defining and refining task organization, conceptual ideas, and the general layout of screens. Thus, hand-drawn sketches of screens can be easily be developed and used very early in the development process. This tends to be the advantage of the hand sketches. Many usability problems can then be identified and corrected quickly. Sketches are also suitable for use by the entire development team, giving everyone a sense of what the real design issue are. Sketches require no large investment of time nor money and they are very portable, placing a few restrictions on where the testing may occur. Sketches can also be quickly modified and iterated as many number of times as needed. Because there has to be no emotional investment in coding and the status quo. There is no necessity for team members to defend something already created from the hard work. Thus, screen sketches are rough approximation and rough approximations often yield more substantive suggestions or critical comments than the actual screen drawn version. Their draft or unpolished look greatly softens the attitude that everything is cast in concrete. Sketches can also be used to define a system's requirement. But along with all these advantages, we still have some disadvantages. To list a few, there could be a disadvantage. This could be a disadvantage because hand drawn sketches are rough approximations. They can only suggest the final layout of the interface and they are just limiting in helping understand the system navigation and flow and are a demonstration device driven by a facilitator with the user assuming a more passive role. That is, a user is not at all considered in this prototype. They are usually restricted to the most common user tasks. As a result, they pose limited usefulness for the usability testing. So now, having seen about hand sketches and scenarios, we shall next move on to the sketch creation process. Storyboards are sequences of sketches or screen layouts that reflect an interaction. Sketch the screens by determining the source of the screen's information, the content and the structure of individual screens and the overall flow of screens. Use an erasable medium so that as ideas are explored and changed, the modifications will be easy to make. Sketch the screens needed to complete each task in the workflow. First, sketch the most common, critical, or frequent activities, following them from beginning to end. Then go back and build for some more exceptions in them. Try out all selected metaphors and modify them as necessary. Make sure the major user objects are very obvious. Avoid getting into too much of details. And most important is the overall screen flow, its order, its structure. Thus, approximate the position of controls simply to verify where it exactly fits. Exact positioning shall come later or will come later in the further stages. Sketch the screens as a team including at least one user in it. To avoid solidifying the product too soon, develop some online prototypes only when everyone agrees to this complete set of screens and have been satisfactorily sketched. Let us move on to interactive paper prototypes. Interactive paper prototypes is another simple low fidelity prototype which involves use of common office supplies such as post-it notes, transparencies, markers and scissors. Menu bars, pull down menus, pop up windows, screen bodies, and so on, reflecting the system tasks are created using using these medias. Then the components are manually manipulated to illustrate the dynamics of the software. The purpose of this kind of prototype is to provide a sense of dynamics of a program without actually having to build a functional version of it. The objective again here is to create a rough vision, not a polished piece of art, just to elicit substantive suggestions and critical comments. The goal, thus, here is not to show how the system or a website will look like, but to assess if people can easily use it or no. So, the advantages of interactive paper prototypes are that it is more illustrative of program dynamics than just a simple screen sketch. System components can be manipulated to demonstrate the interactive nature of the system, and other paper prototypes advantages are generally the same as that they are already been described in hand-drawn sketches and scenarios. Thus, the disadvantages are also similar to those of the hand-drawn sketches. They are only rough approximations. They are just demonstrations and not exercises, and they are driven by facilitators and not the user, and they possess limited usefulness for usability testing. Let us now move on to programmed facets. So, these programmed facets are used to provide a realistic software view of a real program and to illustrate some of the program's functioning. A programmed facet can thus be created using prototyping tools such as Microsoft PowerPoint and Visual Basics. A facet is a very shallow and duplicating only a small portion of what is ultimately intended in both depth and breadth. Because of this shallow nature, it is best described as medium fidelity to high fidelity prototypes. Examples of finished dialogues and screens are for some important aspects of the system are constructed and viewed by making use of such prototyping tools. So, what could be the possible advantages? What is visible can provide a good impression of finished design. Thus, programmed facets also provide a good detailed specification for writing code and can be vehicles for the actual collection of data. And to list out some disadvantages, firstly, it's a highly polished product and can foster a sense of finality because of its appearance. Significant reorganization or restructuring suggestions may be inhibited with a focus simply being on the screen cosmetics. And secondly, the false expectation that a real thing is only a short time away and may be easily created, even though much work still remains to be done. Thus, a programmed facets are also much more expensive to develop than the paper based prototypes and they take much longer time to create. Also, not all functions demonstrated may eventually be used because of the cost, because of its schedule limitations, or lack of user interest. And they may not be practical for investigating more than two or three alternate design approaches. Now, let us move on to prototype oriented languages. So, these prototype oriented languages are used to present an example of completed dialogues and screens for some parts of the system. Prototypes can be constructed using programming languages that support the actual programming process. Some of the examples include Power Builders, Visual Basics, and so on. Using these tools, a high fidelity real program can be created to illustrate some of the program's functioning and mechanics of the interface. An advantage of having a prototype oriented language is that it may include the actual code needed for the system. Otherwise, advantages are generally same as that of our programmed facets. And similarly, what are the disadvantages of prototypes created using programming languages? Like a programmed facet, a danger is that a highly polished product can foster a sense of finality because of its appearance, inhibiting reorganization or restructuring suggestions. The focus simply being on the screen cosmetics. And again, rest of the disadvantages that we have already seen in case of programmed facets also apply for the prototype oriented languages.